In section 2.7, we're going to be talking about parallel lines and transversals. So a little bit of vocabulary. A transversal is any line that intersects any other line. So in this case, our transversal is going to usually intersect parallel lines. So I'm just going to write that. We're going to be identifying our transversal, and we're going to be identifying our parallel lines. Congruent, we are hoping that you know what congruent is. Congruent is the equal measures. So if two angles are congruent, they have the same angle measure. If two segments are congruent, they have the same segment measure, the same distance. Okay. And lastly, parallel lines, they have the same slope. And because they have the same slope, that means they never intersect. Okay. So let's take a look at these new vocabulary words, these new postulates, and identify that with a picture. So this section is important because this is where your Unit 2 project is going to come from. You need to understand all these different postulates in order to do your project. So please make sure that you are writing these down. So the corresponding angles postulate, the word corresponding is going to mean in the same position. So when you are looking at these angles, they are in the same position, but just somewhere different in the picture. So if two parallel lines are cut by a transversal, here we have our two parallel lines. They never intersect, and sometimes you'll know they're parallel because they're going to mark them with arrows going the same way. So that's how we will know that they are parallel. And in this case, my transversal is this line right here. It's cutting through, it's intersecting my set of parallel lines. So when we have this, then the pairs of corresponding angles will be congruent. So these are going to have the same measurement. So in this case, angle 1 and angle 2 are both corresponding because they're in the same position. They're both like above the parallel line to the right of the transversal, above the parallel line to the right of the transversal. So if this were to be 70 degrees, this would also be 70 degrees. They are corresponding, meaning in the same position of my picture. Then we have alternate interior angles. So breaking down these words, anytime you see the word alternate, that's going to mean on the opposite side of the transversal. Alternate, opposite sides, okay? Interior means inside or between the parallel lines. So here are my parallel lines, and interior would be anything between them, okay? So alternate interior angles in this case are going to also be congruent. So again, when you're thinking the word alternate, think, okay, they have to be on opposite sides. And when you see the word interior, you're thinking between, inside between these. So again, if this was like 65 degrees, this would also be 65 degrees. They are alternate interior. Next, we have consecutive interior. And anytime you see the word consecutive, that's going to mean on the same side of the transversal. So alternate means opposite, consecutive means the same. If you memorize that part, the rest should be pretty simple. So consecutive, they are both on the same side. So in this case, 5 and 6 are on the same side. They're on the left of my transversal. And interior, again, means between the parallel lines. So I'm staying within my parallel lines in the middle area, okay? That's what interior means. So in this case, consecutive interior angles are going to be supplementary. And we are hoping that you remember that supplementary means they add up to 180. So in this case, if I were to set up an equation, I would say that angle 5 plus angle 6 should add up to 180 degrees, okay? So what that means is that if I said angle 5 was 60 degrees and I told you to find angle 6, then you would subtract 180 minus 60 and get 120 degrees for that one. Next, we have alternate exterior angles. So again, with that word alternate, anytime you see alternate, that means opposite sides of the transversal. So here's my transversal, and one of the angles is to the left, and one of the angles is to the right of that transversal. Alternate, that's what that means. One on the left, one on the right. And the word exterior means outside the parallel lines. So here are those parallel lines again. And this time I'm not in between them, I am outside of them. That's what exterior means anytime I see that. So alternate exterior angles are also going to be congruent. Okay, so if this is, I don't know, like 130 degrees, then this is also 130 degrees. And with these, you're going to use the properties that we have learned up until this point. So even if like you're not given something here, I could ask you to find this angle. And so you'd have to go back and use your prior knowledge. We know that this makes a line, so I would subtract 130 from 180 and get 50 here. I could end up using vertical angles. So if I had, let me clear this picture a little bit. If I asked you to find this angle, then you could say, oh, look, they're opposite to each other. Vertical angles, this one's also 50. So you are still going to be using all of these angles. They're not just going to go away. We're just introducing new ones to kind of help you have a better understanding of the entire picture. And the last thing we have here is the perpendicular transversal. We have a transversal line, so remember that's the line that cuts through parallel lines, and it happens to create a 90-degree angle, then that means that all the other angles are also going to be 90 degrees. So they're going to be right angles, or you can label them as 90 degrees. Okay. Okay, so now we're going to go ahead and apply this. We are going to be given only one angle here. Angle 5 is 65 degrees, so this is 65 degrees. And we're going to find the other angles that are asked in parts A, B, C, and D. And we're going to say like how we figured that out, okay? So angle 6 is right here. So we're going to be using the only angle they gave us. And I see that angle 6 and angle 5 are straight across from each other. And I remember that those are called vertical angles. And I also remember that vertical angles are congruent. So because angle 5 is 65, angle 6 will also be 65 degrees. Okay. So for problem B, we are again going to just use the information we are given. So we know angle 5 is 65, and I want to find angle 7. So looking at how those two angles are related, together they make a straight line. And I know that a straight line equals 180. You can either say that they are linear pairs, or you can say that they are supplementary. Essentially, the math that you'll be doing here is 180 minus 65, which is going to give you 115 as your answer. For angle 8, if we want to find angle 8, and again, we are using just the information we were given, that angle 5 is here and angle 8 is here. For this one, we're going to use one of our new terms. And so when I'm looking at angle 5 and angle 8, I see that they are both to the right of this parallel line and below my transversal. Angle 8 is also to the right of this parallel line and below the transversal. So they're in the same position, and those are called corresponding angles. And corresponding angles are congruent to each other, so this is also going to be 65 degrees. And the last one we have here is angle 9. I'm going to clear my picture a little bit. So angle 9 is over here. And again, we were only given angle 5, which is 65. So for this one, I have to do a little bit more work, and I'm going to be using a different definition because there's nothing that says that one is on the opposite side So if I was thinking like some sort of the alternate, right, because they're on opposite sides of the transversal, they're both not inside my parallel lines and they're both not outside my parallel lines. So they're not alternate interior or alternate exterior. So I'm going to have to combine properties here. The one I just did was corresponding, and that said that this is also 65 degrees. And if I use that, I'm going to, part D is going to require two things. That I first use corresponding angles. And then now that I use corresponding angles, I'm able to go further and then say, oh, and now these are linear pairs. Okay, so first I use corresponding, then now I'm using linear pairs, and then I can go ahead and just do 180 minus 65, which is 115 degrees. And that gives me angle 9. So now we're going to apply these to do some algebra. And for some of these, you may have to do what I just did with the last one, which is use several theorems before you can actually set up an equation. And so what I like to do just for practice is you can actually fill in a lot of this information, and you may not need it, but it's just good practice here. So for example, I am going to, because these are across from each other, label these because that's a vertical angle. I also could find the linear pair of these. So I could figure out what this is by doing 180 minus 89. And that's going to give me 91. So this is 91 and this is 91. And I can keep going. So because these are on the opposite side of the transversal and they're interior, this would be 89. And this would also be 91. And because these are vertical angles, this would also be 89, and this would also be 91. So they should all kind of come together and, make sense. It's a one big picture. The angles are going to be repeating themselves when we are finding the measures. So now, because this is only labeling this angle, and I know by doing, vertical angles and alternate interior and all of that, I can set up 5x minus 24 equal to 91. So I'm going to add 24 to both sides. I'm trying to solve for x here because it's asking me to find the value of the variable. And so we are just going to add 24, divide by 5, and I get x equals 23. And that is my answer. Looking at problem B, so in this one I have 126 here and then this equation here. They are both above the transversal and to like the right of the parallel line, so these are corresponding, meaning they are in the same position and they have the same measurement. So I'm actually going to be able to set this equation equal. So because both of them are congruent, I can set the angles equal to each other. So I'm going to apply the distributive property here. 7 times x is 7x. 7 times minus 7 is minus 49 equals 126. I'm going to add 49 to both sides so that they cancel here. I end up with 7x equals 175. And my last step here is to divide by 7. So x equals 25. Okay, and I know previously I stated that there would be arrows signifying that these are parallel lines, so there they are. That's how we are going to know if lines are parallel or not, based on the picture. Okay, which lines, if any, are parallel for example 3? So in order for lines to be parallel, all these theorems and postulates that we talked about need to be true. So if, let's say, I'm assuming these are the ones that look like parallel lines in the whole picture. These are the only set of lines that look like they're parallel. So in order for these to be parallel, my corresponding angles, this angle and this angle, should be congruent because that's it. That is one of the rules that we just learned about. So I need to figure out if 38 plus 70 here is the same as 114. So when I add up 38 plus, it's a 77, I end up with 115. So they are 1 degree off. They are not exactly the same. So you're going to say that the corresponding angles are not congruent. Therefore, these lines are not parallel. Okay, so I know they're only 1 degree off, but somewhere over there where we can't see, they're going to end up crossing each other because they are not exactly the same degree. So they are going to intersect, making them not parallel. Okay, our last example, we have to use this picture, and we are going to be classifying these angles as either alternate interior, alternate exterior, corresponding, or consecutive interior. And just think back about what I said. Alternate means opposite sides of the transversal. Exterior means outside. Interior means inside. Consecutive means on the same side. And corresponding is on the same position. Okay, so here we go. We have 2 and 6. So I have 2 here and 6 here. And so we're going to be using these names. I know that this line and this line are not parallel, but I can still use the same descriptive words, such as alternate interior, exterior, and so on, to label these lines. So I wouldn't be able to solve for them because they wouldn't be congruent to each other, but I can still use these words to describe them. So 2 and 6 are both kind of like below this transversal and to the right of their lines. So these are going to be corresponding. Okay. Angles 1 and 7, they're both on the outside of these lines. So outside means exterior, and they're both on the opposite sides of that transversal. So that is alternate exterior. I'm going to clear my picture here between them. Next, we have 3 and 8. So 3 is here, 8 is here. They're on the same side of the transversal. They're both above, so that's going to be the word consecutive instead of alternate. And they are both within the 2 lines, so they are interior. Numbers 3 and 5. So 3 is here, 5 is here. They are on opposite sides of that transversal, so that's the word alternate. But they are both within their lines here, so that's interior. And the last one, we have 2 and 6. So 2 is here, 6 is here. They are on the same side of the transversal, and they are also, so I'm thinking 2 things, either consecutive, but then they are not both either both inside or both outside. So then I evaluate again, and they're actually corresponding. So they're in the same position, both like under the transversal to the right of the line, under the transversal to the right of the line. Repeats itself as the first one. So just another way to look at it. And that is that. So you're going to have to, for your project, apply all of these terms into your project. So again, anytime it's saying alternate, think opposite side of the transversal. Interior is within your parallel lines. Exterior is outside your parallel lines, corresponding in the same position. And consecutive means on the same side of your transversal.